In this video, we're going to take a look at calculus with parametric curves. In our first example problem, we have find the equation of a tangent line for x is equal to t squared minus t, y is equal to t cubed minus 3t minus 1, and we want to find this tangent line at t is equal to 2. So just like in calculus 1, we needed an x value, a y value, and then we needed to evaluate the derivative at that point where we're looking for the tangent line. We need the same information. The work to get there is just a little bit different. So we need an x value at t is equal to 2. So if we plug 2 in for t, we would have 2 squared is 4, minus 2 is 2. So x is equal to 2. And then if we plug 2 in for t, y would be 2 cubed is 8, minus 6 is 2, minus 1 is 1. And now we need to take the derivative. And when you're taking the derivative of parametric equations, we're going to have dy dx is equal to dy dt divided by dx dt. So here we have the derivative of y with respect to t goes in the numerator. So we're going to take the derivative of our y is equal to t cubed minus 3t minus 1, which gives us 3t squared minus 3 divided by the derivative of our x with respect to t. So the derivative of t squared minus t is 2t minus 1. And now we need to evaluate this at 2. So if we plug 2 in here, we have 2 squared is 4, times 3 is 12, minus 3 is 9. So we would have dy dx evaluated at 2 is 9 over 2 times 2 is 4, minus 1 is 3. So our slope at t is equal to 2 is 3. So now we're going to use y minus y1 is equal to m times x minus x1. And then we have y minus 1 is equal to 3 times x minus 2. And then we simplify. So y minus 1 is equal to 3x minus 6. And now we add 1 to both sides. And we get y is equal to 3x minus 5. In this next example, we want to find the second derivative of a parametric equation. And in order to find the second derivative, we're going to first need to find the first derivative. So we have, again, dy dx is equal to dy dt over dx dt. So we have the derivative of y with respect to t is going to be the derivative of t cubed minus t, or 3t squared minus 1, divided by the derivative of x with respect to t, which is 2t. And now, in order to take the second derivative, it's a little different than the way we did it in Calc 1, where we're not going to just take the derivative of the first derivative to get the second derivative. The second derivative is going to be equal to d dt of dy dx, or of our first derivative. So we still need to take the derivative of the first derivative, but it's only going to go in the numerator. And then in the denominator, we're going to have dx dt, which we've already found to be 2t. So we know that 2t is going in the denominator. And now, in order to find the derivative of our first derivative, we're going to need to use the quotient rule. So we have 2t times the derivative of 3t squared minus 1, which is 6t minus 3t squared minus 1 times the derivative of 2t, which is 2, all divided by 2t squared. And now we're going to simplify. So I have 2t times 6t is equal to 12t squared minus, I have 2 times 3t squared, and this negative out front is going to give me minus 6t squared, and then we have 2 times negative 1 is negative 2, and then this negative sign out front makes it positive. So plus 2, all divided by 2t squared times 2t. So we can do 2t squared could be written as 4t squared, and then times 2t. So we're going to have 8t cubed in the denominator. And now we can simplify a little more and say that this is 6t squared plus 2 divided by 8t cubed. And then if you wanted to factor a 2 out, we also could do that, and we could call it 3t squared plus 1 divided by 4t cubed. And that's how we use calculus with parametric curves.